Amazon S3, Simple Storage Service. Simple Storage Service. 1. Amazon S3 is an online storage service, like a big online storage locker in the cloud. 2. It stores all types of digital files, photos, videos, music, documents, etc. 3. Accessible from anywhere, anytime. 4. Offers high security and reliability. 5. Organize your files into folders, called buckets. 6. Can handle small to massive amounts of data. 7. Suitable for both personal use and businesses of all sizes. Use cases. 1. Backup and restore. Amazon S3 is widely used as a secure and reliable solution for backing up critical data. It can also be used to restore the data when needed. 2. Content distribution and hosting. S3 can serve as a cost-effective and scalable way to distribute content, such as hosting websites, or distributing media files like music, videos, and images. 3. Data archiving. Amazon S3 Glacier and S3 Glacier Deep Archive are used for long-term archival storage for compliance and regulatory needs, due to its durability and low cost. 4. Big data analytics. S3 can store and analyze large datasets for applications such as machine learning, data mining, and predictive analytics. 5. Disaster recovery. S3 can serve as a key component in disaster recovery strategies due to its geographic diversity, ensuring data remains safe in the event of a regional outage. 6. Data lakes. Amazon S3 is often used as the storage layer for data lakes, which contain vast amounts of raw data in various formats. 7. Application hosting. S3 can store static files for web applications, including HTML, CSS, JavaScript, and image files. 8. Software delivery. Software and mobile app developers can use S3 to store and distribute application binaries, container images, and libraries. 9. IoT data storage. Data from IoT devices can be stored, processed, and analyzed using Amazon S3. 10. Machine learning. Amazon S3 can be used to store training data and model outputs for machine learning workflows. Object storage. 1. Object storage manages and manipulates data as distinct units, called objects, which include the data, metadata, and a globally unique identifier. 2. Unlike hierarchical storage, tree-like structure, or block storage, uniformly sized blocks, object storage provides a flat address space for easier scalability. 3. It is designed to be highly scalable, making it ideal for storing large amounts of unstructured data such as photos, videos, and sensor data. 4. Each object is independent and doesn't require a specific location for storage, allowing flexible data retrieval. 5. The included metadata can detail the content of the data, its handling instructions, origin, etc., aiding in organization and access management. 6. Common use cases include cloud storage, backup and archiving, and big data analytics. 7. Popular object storage systems include Amazon S3, Google Cloud Storage, and Microsoft Azure Blob Storage. Block storage. 1. Block storage involves storing data in volumes or blocks, each acting like an individual hard drive. 2. Controlled by a server-based operating system, commonly used in SAN environments. 3. Ideal for quick, random read and write operations, common for traditional databases. 4. Offers flexibility, blocks can be structured and formatted based on the desired file system. 5. Suitable for storage-intensive, high-performance, low-latency applications like databases. 6. Compared to object storage, block storage scales vertically, may face limitations for large-scale data needs. File storage. 1. File storage involves storing data in a hierarchical structure, much like a traditional file system with directories and files. 2. Files are identified by a name and a specific path leading through its directory structure. 3. Operates through file-level protocols such as NFS or SMB, commonly used in NAS systems. 4. Ideal for shared content or collaborative scenarios where multiple users need to access and edit the same files. 5. Simpler to use and understand than block or object storage, but not as scalable. 6. Performance may degrade with very large quantities of files or deeply nested directory structures. S3 buckets. 1. AWS S3 buckets are containers for storing data in Amazon's simple storage service. 2. Each bucket can hold numerous diverse objects, including data and descriptive metadata. 3. S3 service is a flat structure, but a logical folder structure can be imposed using object key names and delimiters. 4. Features like versioning, lifecycle management, and different security options are available for buckets. 5. Buckets can be configured for static website hosting. 6. Buckets are region-specific, and data is stored across multiple devices in multiple facilities within a region. Bucket limitations. 1. You can create between 1 and 100 buckets in each AWS account. You can increase the bucket limit to a maximum of 1,000 buckets by submitting a service limit increase. 2. Amazon S3 buckets are owned by the account that creates them and cannot be transferred to other accounts. 3. Bucket names are globally unique. There can be no duplicate names within the entire 53 infrastructure. 4. Once created, you cannot change a bucket name. 5. Buckets are permanent storage entities and only removable when they are empty. After deleting a bucket, the name becomes available for reuse by any account after 24 hours if not taken by another account. 6. There's no limit to the number of objects you can store in a bucket. You can store all of your objects in a single bucket, or organize them across several buckets. However, you can't create a bucket from within another bucket, also known as nesting buckets. 7. By default, you can create up to 100 buckets in each of your AWS accounts. If you need additional buckets, you can increase your account bucket limit to a maximum of 1,000 buckets by submitting a service limit increase. Naming buckets. 1. Be unique across all of Amazon S3. 2. Be between 3 to 63 characters long. 3. Consist only of lowercase letters, numbers, dots, and hyphens. 4. Start with a lowercase letter or number. 5. Not begin with XN, beginning February 2020. 6. Not be formatted as an IP address, i.e. 198.68.10.2. 7. Use a dot in the name only if the bucket's intended purpose is to host an Amazon S3 static website, otherwise do not use a dot in the bucket name. Object overview. 1. In Amazon S3, an object is the fundamental unit of storage, consisting of file data, metadata, and a unique identifier. 2. The file data could be any content you're storing, such as a photo, a video, or a document. 3. Metadata is a set of name-value pairs describing the object, including user-defined metadata or system metadata like the date last modified. 4. The unique identifier, or key, is generated by Amazon S3 for the retrieval of the object. 5. Objects are immutable, meaning the data in the object cannot be changed once it is stored. To change the data, a new object must be created with the same key, which overwrites the existing object. Keys. 1. Unique identifier. Object key is a unique identifier for an object in a bucket. 2. Object identification. A combination of bucket, object key, and version ID, if versioning is enabled, uniquely identifies an object. 3. Data map. S3 works as a data map, linking bucket plus key plus version to an object. 4. Hierarchy inference. There's no real hierarchy in S3, but hierarchy can be inferred using prefixes and delimiters in an object key name, introducing a folder concept. 5. Key name. Rather than actual folders, S3 provides long key names. 6. Object address. Each object is uniquely addressed via a combination of web service endpoint, bucket name, key, and optional version. For example, in https://docx3.s3.west2.amazonoz.com/photos/puppy.jpg, doc example bucket is the bucket name and photos/puppy.jpg is the key. Versioning. 1. Versioning allows for the storage of multiple versions of an object in the same bucket. 2. It can be used to preserve, retrieve, and restore every version of every object in an Amazon S3 bucket, which can help in recovery from unintended actions or application failures. 3. Amazon S3 can store all objects if multiple write requests for the same object are received simultaneously. 4. When versioning is enabled, Amazon S3 automatically generates a unique version ID for the object being stored. 5. In a single bucket, two objects with the same key but different version IDs can exist, for example, two versions of dolphins.jpg with different version IDs. Value. 1. Value/size represents the actual content being stored. 2. Sequence of bytes. Object value can be any sequence of bytes. 3. Specific byte range. The value can represent a specific range of bytes within an object. 4. Size range. Objects in S3 can range from 0 to 5 terabytes. Metadata. 1. Object metadata. Amazon S3 maintains system metadata for each object. 2. Metadata processing. Amazon S3 processes metadata for purposes like object management. 3. Metadata categories. System metadata is of two types. 4. S3 controlled metadata. Some metadata, like creation date, is controlled by Amazon S3. 5. User controlled metadata. Some metadata, like storage class and encryption status, can be controlled by the user. Organizing data using tags. 1. Tag definition. A label assigned to an AWS resource with a key and optional value. 2. Data categorization. Tags categorize AWS resources or data. 3. Tag utility. Tags assist in tracking data by criteria such as project or owner. 4. S3 tags. Key value pairs in Amazon S3 applied to buckets or individual objects. 5. Management and insights. Using tags aids in storage management and data usage insights. 6. Tag limitations. New tags on a bucket don't apply to existing child objects. Bucket tags. 1. Bucket tags are used to track storage costs or other metrics by labeling Amazon S3 buckets with cost allocation tags, which are key value pairs. 2. AWS uses the activated cost allocation tags to organize your resource costs on your cost allocation report. 3. Cost allocation tags can only be applied to buckets and not individual objects. 4. There are two types of cost allocation tags, AWS generated tags and user-defined tags. The AWS generated tag, created by, is applied automatically after an S3 create bucket event. 5. User-defined tags are created and applied by you to your S3 bucket. 6. After creating and applying user-defined tags, you can activate them using the Billing and Cost Management console for cost allocation tracking. 7. Cost allocation tags appear on the console after enabling AWS Cost Explorer, AWS Budgets, AWS Cost and Usage Reports, or Legacy Reports. 8. After activating the AWS services, they show up on your cost allocation report, allowing you to use the tags on your report to track your AWS costs. Object tags. 1. Object tagging, used for data categorization and querying. 2. Tagging timing. Tags can be added during or post-upload. 3. Rules. You can associate up to 10 tags with an object. They must have unique tag keys. 4. Tag keys can be up to 128 characters in length. 5. Tag values can be up to 255 characters in length. 6. Key and tag values are case sensitive. Benefits of tagging. 1. Object tags allow for fine-grained access control of permissions, such as granting a user permission to read only objects with specific tags. 2. Object tags enable nuanced object lifecycle management, where a tag-based filter can be specified in a lifecycle rule alongside a key name prefix. 3. In Amazon S3 Analytics, filters can be configured to group objects for analysis by object tags, key name prefix, or both prefix and tags. 4. Amazon CloudWatch metrics can be customized to show information by specific tag filters. Global visibility. 1. Amazon S3 is a globally viewable service, so you don't need to specify a region to view buckets in the AWS Management Console. 2. Upon creating a bucket, a region must be selected to indicate where the bucket data will reside. 3. The chosen region should be local to your users or consumers to optimize latency, minimize costs, or meet regulatory requirements. 4. For instance, if you're based in Europe, you'd want to create buckets in the Europe, Ireland, or Europe, Frankfurt, regions instead of Asia Pacific, Sydney, or South America, Sao Paulo, to reduce latency and meet legal requirements. Cross-region replication. 1. Cross-region replication enables data storage in multiple regions by replicating your bucket to other regions. 2. It allows you to automatically copy objects from a bucket in one region to a different bucket in another region. 3. You can choose to replicate the entire bucket or use tags to replicate only specific objects with the tags you select. Thanks for watching.